Resit practice paper question number 5. We've got to solve this second order differential equation. We've got double differential in there, second differential, and so that's what makes it a second order differential equation. Remember, it looks a bit like a quadratic equation because we've got an x squared term, which is the second differential, like an x term, which is the first differential, and then a constant. So that's the idea. The first part of this is asking us to form an auxiliary equation, which is a quadratic equation. Let's solve that. And then that will give us the general solution. And the second part of the equation is to, once we've done that, explain why the general solution has that form. And if you look at your tables, you'll see there's a table of general solutions, and so you can use that to help you explain it. And then C, the final part, is a bit like the previous differential equation question. We're given the general solution with a constant in it. In fact, more than one constant. We've got constants A and B. Then we can use initial conditions to find those. But because we've got two constants, we need two sets of initial conditions. We know that when the time is 0, the original charge is 5, and we also know that when the time is 0, the differential is 0. So that's two conditions. So we can do it in theory. So that's the idea. I'll go through each part in turn, but pause at any stage and try and carry on yourself. So let's have a look at part A. Form the auxiliary equation. Well, let's just basically write it down. And if you remember, we let m represent the differential. So that's m squared plus 4m minus 12 equals 0. That's the auxiliary equation. And to solve it, we generally need to factorize. And to do that, we're after making sure that the constant in front of the m squared is 1, and it generally is. Certainly in the sorts of questions you're going to be given, but if it's not equal to 1, we'd have to think about how to get around that. So for this particular auxiliary equation, what we have to do now is to try and solve it. So we know that m squared plus 4m minus 12 equals 0. Factorize. m equals 0. So we think of two numbers, remember, add together to give one of these values and multiply together to give the other of these values. And remember which is which and how to do it. Pause and have a go. They have to add together to give minus 12 and multiply together to give 4, if you remember. So two figures that multiply together to give 4, sorry, add together to give 4, what am I saying, and multiply together to give minus 12. So first of all, think about all the combinations of ways we can make 12. 3 times 4 is 12. 12 times 1 is 12, and 6 times 2 is 12. Combinations of those could add together to give 4 and multiply to give minus 12. Well, because we've got a minus, that means one of these has got to be negative in each of these to make it negative. So how can we get them to make plus 4, plus 6, minus 2? So the factors must be plus 6 and minus 2. And because the right-hand side is 0, that means that either this bracket or this bracket is 0. So m plus 6 equals 0, or m minus 2 equals 0. And this means that m equals minus 6, and this means that m equals 2. So those are our two solutions. So we've solved it. We explain why the general solution has the form this. Well, if we look at our table, we can see that we've got two real and different solutions. And so it must be of this form. So that's your explanation, because we've got two real and different solutions. We now know what K1 and K2 are, and so we can put them in. K1 is going to be minus 6, and K2 is 2, or the other way around. It actually doesn't really matter which is which, but we know that our general solution is y equals a e to the minus 6x plus b e to the 2x. So we've now come up with our general solution. Okay, so now we've got our general solution. Remember, it's a general solution because we don't know A and B. So in part C, you're asked to find a particular solution given some initial conditions, as we've discussed. In the exam, you might well be given the general solution and then asked to carry on and put the initial conditions in. So, to do this, we can put in, when t equals 0, or actually we've used x, but this represents t and q, so actually we're using q and t in here. We've got that q equals a e to the minus 6t plus b e to the 2t. So we've got some values. We know that when t equals 0, q equals 5, so we could put them in here and find one equation. But we need a second. We know that when t equals 0, differential 0. So we've got to differentiate this equation to get the q by dt. And if you look at your table of differentials, when you differentiate an exponential function, the power comes down, but then the power remains unchanged. So all we get is minus 6a e to the minus 6t plus 2b e to the 2t. So we've now got two equations, one for q and one for the differential. So put our initial conditions in. When t equals 0, q equals 5, and when t equals 0, dq by dt equals 0. So see if you can write down the two equations that we get. So hopefully you got something like this. When q equals 5, t equals 0, so minus 6 times 0 is still 0, so the power of e is 0, and the second one, the differential, is 0, and so 0 equals minus 6a e to 0 plus 2b e to 0, again when t equals 0. But anything to the power 0 is 1, so all of these come down to 1. So we can actually simplify this an awful lot, and we get 5 equals a plus b, and 0 equals minus 6a plus 2b. So we've got two equations and two unknowns, simultaneous equations, so we can find them. We can either make a substitution, which means that we just maybe take the b over here in the top equation, so a equals 5 minus b, and substitute that in here instead of a, or we can make a's or b's the same in these equations by multiplying maybe by 2 so that the b's are the same and eliminating. Either way, you can come up with values for a and b. Have a go. Again, I'll have a look at it myself, and then you can have a look at your solution after you've tried it. Okay, so, well, I've done it both ways, so let's have a look. First of all, from equation number 1, I've rearranged it for a equals 5 minus b. Then in equation 2, instead of a, I've written 5 minus b. So that's this bit here. Expanding out this bracket, minus 6 times 5 is minus 30, minus 6 times minus b is plus 6b. So now adding b's, 6b plus 2b, that should be a b there, is 8b. And then taking the 30 over the other side gives me 30 equals 8b, so b equals 3.75. putting these values back into 1, so a equals 5 minus 3.75, which is 1.35. Or I could, going back to my original equations, times this equation by 2, so I've got 2b in both equations. So that's what I've done. Multiply equation 1 by 2 to get this. Rewritten equation number 2, where now b's are the same. So I've subtracted equation 2 from equation 3. I've done it that way round because I've got 2a minus minus gives me plus 6a. It would work the other way, but a bit more awkward. So I end up with 10 equals 8a, a equals 1.25, and substituting back into 1, I get b equals that. Same answer. So there's your solution to question number 5. Finally, of course, I forgot to say we could now put these values for a and b back into the general solution to end up with this as your final particular solution.